Imagine being described as the tall, thin, blue intruder walking slowly, not by a spy agency, but by a creature the world ignores. 30 years of recordings, locked in a vault, and now decoded, reveal prairie dogs tagging humans with laser precision. Less than 2% of their sprawling megacolonies survive, and their underground families catalog us in disturbing detail. What forces wiped out their empires, and why did no one notice the messages until now? Deep beneath the Arizona grasslands, a scientist named Con Slobodchikoff spent 3 decades gathering what most experts dismissed as background noise. His vault holds thousands of hours of prairie dog vocalizations, every chirp, yip, and alarm, each one frozen in time on magnetic tape and digital files. This is not just a pile of random squeaks. Each recording is labeled with the date, colony, predator type, and even the color of the shirt worn by the human intruder. The sheer scale is staggering. 30 years of fieldwork, spanning generations of prairie dog families, all cataloged with the precision of a forensic archive. Slobodchikoff's method was relentless. He stationed microphones at burrow entrances and waited, sometimes for days, for the right moment. When a coyote slinked by, the prairie dogs barked their warning. When a human in a red jacket crossed the field, the calls shifted. Every sound was captured, then run through sonogram analysis back in the lab. The sonograms, those jagged, stacked chevron lines, became the Rosetta Stone for decoding meaning. Each pattern, each cluster, matched to a specific threat, a shape, a color, or a speed. Playback experiments proved it. When the recording of a hawk alarm was played, the colony dove for cover. When the human call echoed out, sentinels stood up, scanning for the 2-legged invader. Skeptics demanded proof, so Slobodchikoff delivered. He ran statistical tests, built neural network models, and challenged colleagues to tell the difference between calls. Humans failed. The computer did not. One translation from the archive stands out. A call pattern linked to the approach of a tall, thin human in a blue shirt, walking slowly. The sonogram signature, 3 sharp peaks and a long, trailing valley, became a fingerprint for that intruder. As Slobodchikoff wrote, "We have been decoding them for decades. The patterns are there, if you know how to listen." This is not a handful of cherry-picked examples. It is a mountain of data, cross-checked, replayed, and confirmed by both animal and machine. The archive stands as a monument to scientific rigor and a warning. If this is what has been hiding in plain sight, what else are these creatures recording about us? Like and subscribe to Stellar Insights 42 if you want to see what the vault unlocks next. In the late 1800s, a single prairie dog colony in Texas stretched farther than the eye could see. Estimates put it at nearly 25,000 square miles, a living city beneath the plains. Early accounts claimed hundreds of millions of animals tunneled beneath the grass, their burrows packed so close that a horse's leg could snap through the ground without warning. From the Dakotas to New Mexico, the Great Plains pulsed with a network of these underground metropolises, each one humming with its own social code. Life in these towns was not chaos. Every colony broke down into tight-knit family groups called coteries, where a handful of related females, a single breeding male and their young shared a cluster of burrows. These coteries formed the basic unit of prairie dog society, defending their patch with a mix of vigilance and constant communication. Males did not stick around for long. When the threat of inbreeding loomed, they vanished into neighboring wards, carrying their dialects and secrets with them. But the prairie dog empire did not last. By the turn of the 21st century, less than 2% of their historic range remained. Bulldozers flattened colonies to make way for shopping centers and highways. Poisoning campaigns that started in the 1900s finished what the plows began. In Texas, where millions once thrived, scattered pockets survive, tiny outposts surrounded by a hostile world. The collapse is more than a numbers game. Prairie dogs are not just another rodent. They are the architects of the grassland ecosystem. Their tunnels aerate the soil, their alarm calls warn antelope and owls, and their presence keeps the prairie alive. When a colony falls silent, the entire landscape changes. Today, every remaining colony is a fortress under siege. Their complex social networks, once sprawling and robust, are now fragile threads stretched across shrinking patches of land. Each coterie depends on its neighbors for survival, passing information about predators and food, teaching calves the dialects and warning calls that kept their ancestors alive. The loss of a single group can unravel the entire network, silencing voices that once carried for miles. If the remaining 2% vanish, the grasslands lose their sentinels. The stakes are not just scientific curiosity, but the survival of an entire ecosystem built on the backs of a species now teetering at the edge. Every prairie dog colony is a living sensor grid, tuned to the smallest ripple of danger on the plains. When a shadow crosses the grass, a sentinel stands upright, scanning the sky or horizon. The first sound is never random. It is an alarm, sharp and urgent, and it carries information far beyond a simple cry of fear. Prairie dogs don't just shout danger. They encode the type of threat, the shape it casts, the speed it moves, and even the direction it is coming from. A coyote slinking low triggers a series of rapid, clipped barks, staccato bursts that ripple through the colony. Hawks diving from above get a different call entirely, pitched higher, stretched out, almost slicing the air. Humans are something else. The alarm for a human is longer, with a trailing edge that seems to linger, as if the colony is trying to hold the warning in the air just a moment longer. The rules behind these alarms are biological, but they are also mathematical. Sonograms reveal that each call is built from patterns, stacked chevrons, repeated peaks, valleys that mark out the signature of a threat. Shape matters. When researchers dragged cutouts across the field, an oval, a triangle, a circle, prairie dogs responded with new calls, patterns never used for coyotes or hawks. A circle signaled a human head, an oval could mean a hawk's silhouette, a triangle signaled something unknown. The calls changed not just with what the colony saw, but how it saw it. Speed is just as crucial. A fast-moving predator triggers a rapid-fire sequence, the tempo ratcheting up with every pulse. A slow approach, like a person creeping through the grass, draws out the alarm, slower and more deliberate, as if the colony is measuring intent. These are not gut reactions. They are calculations, broadcast in real time to every ear underground and above. The all clear is just as structured. When the danger passes, a prairie dog will leap into the air and yip, a move called the jump yip. One animal jumps, then another, and soon a wave rolls across the colony. It is not panic, but a contagious signal. The coast is clear. Go back to business. This wave can sweep through hundreds of animals in seconds, sinking the entire town in a single coordinated act. Each of these signals is a data packet, shape, speed, context, and intent, all compressed into sound. The colony acts as a single intelligent agent, processing threats and updating every member. The question that haunted researchers for decades was simple: could a machine ever parse this code and reveal the grammar hiding inside? The answer, as it turns out, was waiting in the patterns all along. Pattern computers engineers locked themselves in a windowless lab with one goal: force the world's most advanced AI to crack the code, hidden in Slobodchikoff's mountain of prairie dog sonograms. They fed the system everything: 30 years of alarms, panics, gossip, and warnings, each labeled with predator, color, speed, even the weather. The machine didn't just listen, it learned. At first, the results looked like chaos. Sonograms stacked in endless grids, patterns flickering, nothing but noise. But then a decision trace began to form, a digital fingerprint of meaning. The AI's pipeline sliced every call into micro-patterns, hunting for the rules that turned chirps into sentences. For each alarm, the system mapped which frequencies matched which threats, which clusters signaled color or speed, which sequences meant human, coyote, or hawk. The confusion matrix glowed with confidence. For every 100 calls, nearly 90 matched the human-labeled translation. Not just danger, but fast coyote, slow blue human, oval shadow moving west. Connell, a machine learning specialist on the project, watched as the AI's logic unfolded in real time. "It is like watching a Rosetta Stone being written," she said. "You see the rules snap into place. Adjectives before nouns, speed modifiers stacking up. Even dialects Arizona calls drift from New Mexico's, just like regional English." The AI didn't just mimic Slobodchikoff's findings, it exposed new layers. Decision traces revealed grammar trees branching out. One call mapped to small, fast white person, another to tall, slow yellow intruder. The system flagged error zones, places where the calls blurred, where gossip and social chatter defied translation, where the colony's secrets stayed locked underground. Validation artifacts rolled in, confusion matrices, accuracy bars, and blind test results. The numbers didn't lie. About 90% of alarm calls could be decoded, their meaning confirmed by playback and human review. But the system would jam on the endless social chatter. No pattern, no translation. The AI's black box hit a wall. Prairie dog gossip. Was it code, status updates, some underground conspiracy? Even the engineers couldn't say. Slobodchikoff called the breakthrough the most advanced animal speech decoding on Earth. But he also warned, what if they are saying things about us we cannot even imagine? The machine had learned to translate alarms, describe the enemy, measure the threat. But the real story was still buried in the static, waiting for the next decode. Don't miss what is coming. Like and subscribe to Stellar Insights for 2 now. Arizona colonies have their own accent. The warning calls echo sharp and clipped across the dry grass, a sound that is instantly recognizable to locals, but baffling to outsiders from New Mexico. A coyote crossing the boundary between 2 towns might trigger a flurry of alarms, and the pitch and rhythm change as the message passes from one colony to the next. Researchers mapped these differences, finding that a threat call from Flagstaff carries a different signature than one from the plains near Santa Fe. The dialects are not just quirks, they are the product of a slow, careful education. Calves spend years, sometimes more than a decade, learning the subtle twists of their family language. Every chirp, every yip, is shaped by the elders. The process is not instinct. It is cultural inheritance, passed down like an heirloom, one sound at a time. A calf's first year is spent in near silence, listening from inside the burrow as adults trade warnings and gossip overhead. By the time it ventures out, it is already beginning to mimic the local accent, practicing the calls that will one day keep its family alive. The lessons stretch on for years. A single mispronounced alarm could mean the difference between safety and disaster. The stakes are high, and the learning curve is steep. But dialect is not just about survival. It is a wall, too. Prairie dogs from Arizona and New Mexico may share the same landscape, but their calls do not always translate. A warning from one side of the border might sound like nonsense to the other. Even closely related species, black-tailed and Gunnison's prairie dogs, cannot break the language barrier. Their worlds run parallel, but their voices are divided. The result is a patchwork of cultures hidden beneath the grass. each one with its own rules, its own memories, its own secrets. The next mystery waits in the shadows of these conversations. Endless underground chatter, the kind that even the best AI cannot yet decode. A microphone left running outside a burrow captures a low, restless hum. Waves of prairie dog chatter roll through the air with no sign of threat, no visible change in behavior. For years, researchers cataloged these sounds as background noise, but the archive tells a different story. Hours of gossip, status updates, and invisible negotiations pulse through the tunnels. The AI that could slice alarms into perfect translations hits a wall here. The social calls are dense, tangled, and impossible to map. Slobodchikoff calls it the underground code, conversations that never surface, topics that may never be known. Are they trading secrets, plotting, or just keeping tabs on who is in charge? The mystery does not stop at the colony's edge. Grassland birds like curlews have learned to eavesdrop on prairie dog chatter. A recent study found that when curlews nest near active colonies, their survival rates jump by as much as 10%. The alarm system is not just for prairie dogs. It is a public broadcast and a lifeline for the entire ecosystem. The colony becomes an information hub, a living intelligence network humming beneath the grass. In January 2025, a milestone appeared in the literature, drawing comparisons to the legendary King Solomon's ring, the mythical device that let humans speak with animals. The report confirmed what researchers had suspected. Prairie dogs use referential calls, describing dangers that are not even present. They talk about absent threats, passing warnings down the tunnels like folklore. For the first time, scientists recognized mammal speech that can reference the unseen. The implications stretch far beyond the prairie. Slobodchikoff's new project, Zoolingua, aims to build a translator for pets, an app that could turn your dog's barks into sentences using prairie dog research as a blueprint. If the world's most advanced animal communication system is finally decoded, what happens when the surveillance turns inward? What if your own pet starts reporting on you? The chatter under the grass remains unsolved. The ecosystem listens. The machines are listening too. If you want to know what they will decode next, like and subscribe to Stellar Insights 42. The story is not finished, and the next secret could be about you. Right now, the line between human language and animal intelligence grows thinner with every decoded call. As artificial intelligence cracks open these hidden worlds, our own actions, urban sprawl, and habitat loss echo louder in the silence left behind. The real question is not what prairie dogs say about us, but whether we are listening before their voices vanish. What do you think they would warn each other about next?